Now let's convert from exponential form to logarithmic form. We know that if I want to convert to logarithmic form, I need to write the word log. I know I need a base. I know this would be the exponent, and then in here the argument of the log is actually the answer of the exponential. So the base is 12, the exponent is 2, and the answer is x. So to convert 12 squared equals x to log form, it would be the log of x base 12 is equal to 2. Remember, a logarithm is just an exponent, so the answer of the log is always the exponent. Before we convert the next one, we should rewrite it in exponential form. So instead of saying the cube root of 64, we should write 64 to the 1/3 equals 4. So I write the log, the base is 64, the exponent is 1/3, and the argument is 4. 64 to the 1/3 is equal to 4. Now the next two, one would be a common log and the last one is going to be a natural log, but we can still start off the same way. We've got y equals 10 to the 6th. I'm going to write the word log. The base is 10, the exponent is 6, and the answer is y. But remember from the last video that when the base of a log is 10, we don't need to write it in. It's implied. So we would write the log of y base 6, and that would be considered a common log. For the e to the x equals 5, similar scenario, I write the word log, the base is e, the exponent is x, the argument is 5, but when the base is e, we use that special word ln, so ln of 5 is equal to x. Remember, ln is the same thing as saying log base e. And writing log with no base, it's implied that it's 10. So let's use our knowledge of converting back and forth from log form to exponential form to look at a few basic properties. So the first property says if you have the log of b, base b, it's equal to 1. And so what they're really asking you here is what this expression log of b base b means. What exponent do I put on b to give me b? And the answer would be 1. But it's easier to see this if we convert it to exponential form. So we would say the base is b, the exponent is 1, is equal to the argument here, which is b. So that makes sense. B to the 1 equals b. Number 2, the log of 1, no matter what the base is equal to 0. And again, we'll convert that to exponential form so that we can see why it works. B to the 0 equals 1. So the log of 1 is always going to equal 0. So just using an example, if you had 2 to the 1, that equals 2. So the log expression, the log base b, 2 of 2, is equal to 1. Anytime the base and the argument are the same, the answer is going to be 1. If we have, say, 5 to the 0, that's equal to 1. So basically, if we have the log base 5 of 1, that's equal to 0. The next two properties are inverse properties. And if you recall from pre-calc 1 when you first learned about inverses, that anytime you take the composition of a function with its inverse, the result is x. So if you take the inverse and you replace x with f of x, you're going to get x back. Or vice versa. If you take a function and you replace x with its inverse, the answer is x. And so these actually fit that form. What we have is a logarithmic expression with an argument that's an exponential expression. So really we're kind of undoing what's being done to x. But again, the easiest way to see this is change the log to exponential form. So the base is b, so it would be b, the exponent is x, and the argument, which would now be the answer, is b to the x. Well, b to the x certainly equals b to the x. When I was first taught this question, or this property, the professor asked, with what color paint will I paint my house white? It's really like a redundant statement. What exponent do I put on b that would give me b to the x? And the answer would be x. Okay. Similarly, If I have an exponential function that has a log in the exponent and the bases are the same, the answer is going to be x. So if I rewrite this in log form, it should help me see it better. So I'm going to write it in log form. The base is b. The exponent goes over here, and the exponent is a log expression. It's the exponent. And then the argument is the answer. And so the log of x base b equals the log of x base b. So before we evaluate a couple of these, let's just I'll give an example of each one of these. If you have the log base 6 of 6 to the x, that's going to equal x. How about a natural log? If I do the natural log of e to the 4th, since that's the same thing as log e to the 4th, that's actually equal to 4. What exponent do I put on e, the implied base here, to give me e to the 4th? Over here, an example of this, if I had 5 to the log base 5x, when the base of the log and the base of the exponential expression are the same, the answer is that argument. Okay. So just before I have you practice some, let's evaluate a logarithmic expression using just converting to exponential form. So if I have the log of 8 base 2, I'm really saying what exponent will I put on 2 that will equal 8? Okay, so 2 to what power gives me 8? And so we could just do this intuitively. 2 to the 3rd power gives you 8 because 2 times 2 times 2 equals 8. Another way of writing that would be just saying 2 to the x equals 8, and what value do I have to put there? We'd say, all right, x would have to equal 3. All right, the next problem, the log of 3 base 9. What exponent do I put on 9 to give me 3? Well, if the base is larger than the argument here, you're going to need a fraction of some sort. So what we're going to do is we'll rewrite this in exponential form. We'd say 9 to some power is equal to 3. And so what I do know is that the square root of 9 is equal to 3. So 9 to the 1/2 is equal to 3, right? The square root of 9 equals 3. So the log of 3 base 9 is actually a half. So at this point, I'd like you to pause the video. And again, I want to really stress that it's really important that you do these practice problems and not just watch me do them, because you just don't learn by watching. You really have to try. And then you can start up the video again and check your work. Okay, let's start with the first one. And again, we're going to look at these kind of intuitively and asking ourselves what power or what exponent would I put on the base to give me the answer. Again, if it helps you to say, all right, let's let the answer be x, and I'll say, okay, 2 to the x is equal to 16, converting the log to exponent form. What do I raise 2 to give me 16? Well, that's 4, because 2 times 2 times 2 times 2 will give me 16. Right. The second one, 3 to the 2nd power will give me 9. 3 squared equals 9. And it's also a good idea, once you solve it, to double check it by looking at it in exponential form. 3 squared equals 9, that makes sense. 25 to what power gives me 5? Well, since I know that the square root of 25 equals 5, that the exponent has to be 1/2. This one, number 4, before I rewrite it, before I answer it, I'm going to rewrite it as 2 to the 1/5. This falls under that category of one of those properties, inverse properties. Basically, we're asking, what exponent do I put on 2 to give me 2 to the 1/5? Well, the answer is 1/5. The log of 100, remember the base is implied to be 10, so 10 to what power gives me 100? And that's 2. Number 6, 5 to what power gives me 1? Well, remember the log of 1, no matter what the base is always 0. Now when your base is an integer and your argument is a fraction, in order to make that happen, we're going to need a negative exponent. When I ask myself 7 to what power, or 7 to the x is going to equal 1 over 49, well, I know 7 squared equals 49, so it would have to be 7 to the negative 2. So 7 to the negative 2 equals 1 over 49. Number 8, 4 to what power gives me 4? That's one of the special properties. The answer is 1. 49 to what power gives me 7? Well, I know the square root of 49 equals 7, so the answer is a half. The log of 1, whether it's a base 10, 5, or e, is always equal to 0. E to the 0 would equal 1. That's how I would check that one. Here is one of the special inverse properties. When the base and the base of the log are the same, the answer is the argument, so that's just going to be 17. Similar property, only in log form. What exponent do I put on 7 to give me 7 cubed? And that's going to be 3. The ln of e to the negative 5, remember, that's the same thing as saying the log of e, base e to the negative 5. And so similar, these really are using the same property. The answer is negative 5. The last one, 10 to what power gives me, remember the base is 10. I'm looking for 10 to some power. It's going to give me 0.01, which is really 1 over 100. So I know 10 squared gives me 100, but I want 1 over 100, so I want negative 2. So how'd you do? If you did not do well on these, I would, practice them again. You can certainly replay the video and pause it and try them again. And also, you can get some practice from the textbook.